Hello guys! Okay, so today we're going to talk about combustion reactions. Combustion reactions are the easiest. They are my favorite. They're literally explosively easy to do. Okay, so let's jump right in. So combustion is the exothermic oxidation of an element or compound. Okay, so basically, with anything that you do, the general format that we're going to have for these, ooh, I like green. Let's highlight with green with a big fat highlighter. Okay, so what you're going to get is anytime you have any hydrocarbon or an alcohol and you add oxygen to it, and it can just be saying that it blows up in air. What supports combustion in air is oxygen, and you are always going to get carbon dioxide and water for the products. So you'll have something with like carbon. Oh, I should probably switch that just a little bit. Super sorry. Okay, so you'll get some sort of something with carbon and hydrogen and possibly an oxygen or so, which is what an alcohol has in it. And then you get O2, okay? And that always makes CO2 and water, okay? Now, when we think about these in terms of our states, okay, we don't really worry too much about the states, but the state of the compound or element, I mean, it depends on what it is, but for the most part, if it's a hydrocarbon, it's probably going to be a gas or a liquid. And then oxygen is always a gas at room temperature. And CO2 is a gas at room temperature. It's what you blow your birthday candles out with, like, right? You blow your birthday candles out with that. That's CO2. And then water is a pure liquid at room temperature. Now, when you're blowing these things up, obviously they are exothermic, which means they're releasing massive amounts of energy, and they usually happen at very high temperatures. So none of these states are going to be perfect. So we don't really care if you have the right states on them. Okay, that's just, it's fine. Okay, so there's a few that we're going to do. Okay, so if you have a hydrocarbon with alcohol, so I'm going to start with just maybe an easy one. So let's say my test question is going to say something along the lines of ethane combusts in air. So it'll be like a sentence like that, and then you have to write the equation and balance it. So first of all, you have to know what ethane is. Eth means I have two carbons. Ane means I have only single bonds. So this is like leftover from our covalent stuff that we had to know. So this is where that's going to come back and get you. You have to know your hydrocarbon nomenclature. So let's put that down. You need to review hydrocarbons. Okay? It's really important. You got to know your hydrocarbon nomenclature to do combustion. That's what makes it easy, though. So ethane is C2H, and we're going to double the number of carbons and add 2 to that. So 2 times 2 is 4, plus 2 more is 6. And this is a gas at room temperature. I don't know how you would know that, but it is. Okay, and it's going to combust in air. Well, what supports combustion in air is O2, and that's a gas at room temperature. And that's going to make carbon dioxide, which is a gas at room temperature, and water, which is a liquid at room temperature. Okay? Again, it doesn't actually matter if you have the states on these. We just want you to be able to know what the reactants are, what the products are, and balance it appropriately. Okay? So on the left side, I've got 2 carbon. I hope you're using a pencil, just in case I screw it up on purpose, because I'm really good at that. Okay, so I'm going to switch to red real quick. Can I get bigger? No, there we go. I want it to be a little bit finer. Nope, I want that one. Okay, so when you are doing these, you have to balance them. And you typically, some people run into a little bit of a conundrum. So I always say oxygen is the devil. You want to balance oxygen dead last if you have to balance it at all, okay? So start with carbon. So carbon, on the left side we have 2. On the right side, we have 1. So again, I hope you're writing in pencil because I'm going to screw this up on purpose, and you're going to see why in just a second. So I'm going to put a 2 in front of carbon dioxide. Now, hydrogens. I have 6 on the left, and I have 2 on the right. So I'm going to put a 3 in front of water. Okay, so if you're keeping track, right? So if I made T-charts, because some people do, some people don't. It doesn't matter. Okay, and oxygen. So carbon, now on the left I had 2, on the right I had 1, and I put a 2 in front, so now I have 2. Hydrogen, on the left I had 6, on the right I had 2. I put a 3 in front, and now I have 6. Oxygen, on the left I have 2. On the right I have 2 times 2. In the carbon dioxide, I've got 4, plus 3 times 1 from the water is 3. So 4 plus 3 is 7. There is no way to turn 2 into 7. So if my oxygens end up with an even number on the left and an odd number on the right, there is no way to fix that. So what I have to do is I have to go back and double everything I already balanced. So I had 1 ethane, so now I'm going to have 2 ethanes. Okay, I had 2 carbon dioxides, so now I need to make that 4 carbon dioxides. I had 3 waters, so now I need to make that 6 waters. Okay, so now on the left I've got, I'm going to have to start my T-charts over again. Okay, so on the left, 2 times 2 is 4, and on the right, 4 times 1 is 4, so carbon is good. On the left, hydrogen, 2 times 6 is 12. On the right, 6 times 2 is 12, so hydrogen's good. On the oxygen, on the left, I have 2. On the right, I have 4 times 2 is 8, plus 6 times 1. So 8 plus 6 will give me 14. Now, what do I put in front of oxygen to turn it into 14 on the left side? I'm going to have to put a 7, okay, which will give me 14 on the left, and now it's balanced, okay? When you look at your balanced equation, I'm sure it said somewhere else in the notes, like on another earlier day, but your coefficients need to be the lowest whole number ratio. So the coefficients here, if you look at them, right, on the left, I've got 2 to 7 on the left, and on the right, I've got 4 to 6. These cannot be reduced anymore because there's a prime number in there. 7's a prime number. These can't be reduced anymore. So 2, 7, 4, 6, I can't reduce those by 2. If it were 2, 6, 4, 6, I could reduce all those by 2, like dividing by 2. But since this is the lowest whole number ratio, I can't reduce this anymore. Okay, so that will come back to bite you sometimes with combustion, so just be careful, okay? All right, let's say I had a metal oxide and oxygen, okay? Or I'm sorry, a metal and oxygen, my bad. So let's say I had, I don't know, I have aluminum. Oh, I want to switch back to purple. Better. Okay, so aluminum is burned in air. So that might be what a typical test question would say. So then you have to figure out, okay, so I have aluminum, right? So aluminum is my metal, and that's a solid at room temperature, with oxygen, which is O2, which is a gas at room temperature. And so when I burn a metal in air, it becomes basically a synthesis reaction. So I'm going to make the metal oxide. So the metal in this case is aluminum, so I'm going to make aluminum oxide. So I'm going to make aluminum, which has a +3 with oxide, which has a negative 2. So common denominator is 6. Multiply 3 by 2 to get 6. Multiply 2 by 3 to get 6. And this is a metallic oxide is always going to be a solid at room temperature. Okay, actually, unless it's a group, it's for combustion. A metallic oxide is always going to be a solid at room temperature. Okay, so now I just have to balance it. Okay, so you see on the left for my, let me switch to red. Yeah. So I have aluminum and oxygen. So on the left, I've got 1 aluminum. On the right, I've got 2. Okay. So again, I hope you're using a pencil. Okay. So I'm going to put a 2 on the left, and now I've got 2, and that seems to be right, but let's see if oxygen is the devil. On the left, I've got 2 oxygens. On the right, I have 3. I can't turn 2 into 3. So what's the common denominator here? It'd be 6. So what do you multiply 2 by to get 6? 3. So we're going to put a 3 in front, and that will give me 6 on that side. And what do you multiply 3 by to get 6? A 2. So we put a 2 in front, and now we have 6. And that works out for oxygen. But now we have screwed up aluminum, because now on the right side I have 4 aluminums, and I only have 2 on the left. So I have to erase the coefficient that I already put. And now I only have 1. Now I'm back to 1. So how do I turn 1 into 4? I put a 4 in front, and now I've got 4 aluminums, and now it's balanced. Do you see how oxygen is the devil? Isn't that fun? Now, a lot of times we're going to ask you to name the products. So if you had to name this product, you would have to write down that the product is aluminum oxide. Notice it's not aluminum 3 oxide, because aluminum, although it is a transition metal, has only a +3 charge. It doesn't have any other charge. It's not variable like some of the others. Okay? Okay, moving on. So if I had a nonmetal with oxygen, I would get a nonmetal oxide. These are typically a little harder, I will say. Yeah, because these are just harder. So let's say I had, which one do I want to go with? Let's say I have sulfur is burned. I don't even have to say that it's burned in air to know that oxygen is what supports combustion. So I'm going to have sulfur, which is a solid at room temperature, burning with oxygen, which is a gas. And this could make a variety of things. It could make SO2, it could make SO3. I think in this case, it's probably going to make SO2, which is a gas at room temperature. And it's already balanced. We're probably not going to ask you anything quite so easy on the test. These are kind of the easy ones, okay? The nonmetal oxide with oxygen, we're not going to ask you that one at all. Don't worry about this one. Like, it's in the teacher notes if you want to see what one looks like. And I do kind of vary my examples from lecture to teacher notes, just so you know. Just to give you some more options when you look at the teacher notes on review day. But anyway, but that's it. That's all you're doing for combustion, right? So either a hydrocarbon or an alcohol burns with O2, makes CO2 and H2O all the time. These are the easy, fun ones. Just make sure you have the lowest whole number ratio coefficients after you balance it. And remember that oxygen is the devil, balance it last because it changes things. Metal oxide with metal with oxygen always makes a metal oxide. These are basically synthesis reactions. Okay, so synthesis and combustion can sometimes be the same thing in this case, but what really makes this a combustion reaction is the fact that it's burned. Okay, and then a nonmetal with oxygen, again, we're not going to give you things that are quite this easy. It's also very hard to predict which nonmetal oxide is going to be more prominent, SO2, SO3. You wouldn't know, but that one's probably more prominent. But anyway, that's all of combustion. Do your homework, do a good job, make us proud.